Okay, Unit 4, Day 7. We're going to start doing some solving quadratic applications, which that just means we're going to put a story problem behind it. Our learning target, I can solve word problems involving quadratic equations. So we've given you several tools last unit, and in the first 6 days of this unit, we've taught you different methods for solving, different methods for graphing. And here in this picture, it's supposed to be, maybe it's almost easier to see in the video than it is in real life, but here's a drinking fountain, the water is coming out, and notice this is supposed to be time and height. So as time goes on, this is how high the water is, and it comes back down. So we can model, anything that's being thrown up in the air and being controlled by gravity is going to have that parabolic shape or like that quadratic shape to it. So here's the y-intercept, which is typically the starting point. So initially the water is this high above the base of the fountain. It goes up, up, up. It peaks probably right around where you would drink it. Kind of ironic that we don't have drinking fountains right now with COVID, but so you probably have not experienced this for a few months, a drinking fountain. Be curious to see if we remember how to do it. Anyway. It's not funny. Anyway, so it goes up, it peaks, and it comes back down, and then it hits the base and goes back down the drain. But for this point here, with the highest point's a vertex, and when it hits the ground, that is a 0, okay, because it has a height of 0. Now just remember, when written in standard form, quadratic, the vertex can be found by using negative b over 2a. That's just review. That was from last unit, Unit 3. The y-intercept is the c on the end. Again, that was last unit. And the zeros can be found using any of those 5 methods we talked about so far. So I think we go back and, we did graphing, we did factoring, we did taking square roots, we did complete the square, and then we did quadratic formula on Monday. So we have 5 methods. Now it's getting to the point where you use whatever method is best for you, whichever one you think is easiest or for that situation. So here's an example. Jason jumps off a cliff into the ocean in California while vacationing with some friends. His height as a function of time can be modeled by this. So if you give me a time, I can tell you how high he is off the ground, where t is the time in seconds and h is the height in feet. So first off, number 1, what we're going to read this and try to figure out which vocab word are we talking about here? Out of these guys up here, y-intercept, vertex, 0, and then go find it. So how high up the cliff was Jason when he jumped? Okay, so what that's asking is when he started, how high was he? Well, when he started is a y-intercept. Okay, so this is a drinking fountain, of course, but he's going to jump up in the air and he's going to fall. Same thing as the water on the drinking fountain. So what I want to find is the y-intercept. The y-intercept is the c. The c is the number on the end. The number on the end is 480. Okay? How high off the surface of the water was Jason after 3 seconds? Well, that's not any in particular point. That's when I'm going to plug in 3. Not this 3, because that's looks like the vertex there. But I'm going to plug in 3 seconds and see what the height is. So I'm going to figure out what is h of 3. So I say h of 3 because right here I'm plugging 3 in for t. So if I plug that in, negative 16, 3 squared plus 16 times 3 plus 480. Put this in the calculator, it'd be 384 feet. So that was just using the function itself, just plugging a time in and finding how high he was at that time. What is the highest point he'll reach? Okay, the highest point, fancy word for that, is vertex. How you find the vertex? Negative b over 2a. It's going to help me find the time, at least, of the vertex. And then I can figure out, so it says down here, when did that happen? I'll be finding that first, and then I'll plug it in and find out how high he was. So negative b over 2a, that'd be negative 16 over 2 times negative 16, because the opposite of b over 2 times a. So this is, see, it's going to be positive because you got both negative, it'll be 1/2. So when did it happen? 1/2 second. And that kind of makes sense. If you're jumping off a cliff, when you jump, after about half a second, you're probably going to be peaking and falling. You're not going to keep going up for 5 seconds. That's like an Olympic jumper if you can jump up and keep going up for that long. So it happened 1/2 second after he jumped. How high was he? So I'm going to do h of 1/2. Okay, so do the same thing he did up here, except for plug in 1/2. And so to save a little bit of time, I'm just going to put down the answer. So I put this in the calculator, 484. So he started out at 480 feet. When he jumped, he jumped 4 foot. That's a pretty good jump. Okay, that's still like, you're getting into the Olympic range of high jumpers if you can jump 4 feet off the ground. So this probably is not a realistic problem technically. So what was the highest point? 484 feet. When did it happen? 1/2 second after he jumped. When did Jason reach a height of 100 feet? Sorry, this arrow's in the wrong spot. Yeah, the arrow should be over here. Let's see here. I think when I copied this over, the arrow was not in the right place. When did Jason reach a height of 100 feet? Well, I'm going to plug 100 in for the height. Actually, no, that was right. I'm sorry. This is correct. We are doing this because I'm plugging 100 in. Here, let me show you why. So 100 equals negative 16t squared plus 16t plus 480. And to solve this, I need this to equal 0 on the other side. So I'm going to have a 0 here. Subtract the 100 over. So this would be t squared plus 16t plus 380. If you notice, I have these 380 being plugged in here. So what it is that I'm not going to be able to factor that. I'm not even going to try to factor that. That'd be a crazy factoring. I'm not sure they're all divisible by 16. There's nothing that, it's not going to be factorable, basically. So I'm just going to use quadratic formula because that's the 5th method I use. It works all the time. So I'm going to plug this in the quadratic formula. So negative b, so negative 16 plus or minus b squared minus 4 times a times c all over 2 times, that has a negative 16. It's just going off the screen. You can't see it. So I use the quadratic formula. It looks like there's 2 answers here because you have a plus and a minus. Now, he did not reach 100 feet, negative 4 seconds, because that'd be going back in time. So 4 seconds before he jumped, that's not what happened. So that one's out. This is the real one. So 5.3, in fact, we'd just say 5.4. That'd probably round to 5.4 seconds. So he jumped, and after about 5.4 seconds, he's 100 feet off the ground. Remember, he was 480 feet off the ground to start with, so that's why he was in the air for so long. He may not survive this jump, I'm not sure. When did Jason hit the water? So now this one, instead of setting equal to 100, we're going to set equal to 0 to begin with. So I'm going to set that function above, negative 16t squared plus 16t plus 480 equal to 0. And you can try to factor this if you want. They are all divisible by 16 if you feel like doing it. You could do complete the square. I would not. Personally, would hate doing complete the square on this because that'd be terrible. So factoring or quadratic formula would probably do the job. So try either one of those out. Try one of them. Maybe pause the video here. Try quadratic formula, try factoring, whatever method you want. Then hit play and I'll have the answers here. But please quiz yourself. Please actually quiz yourself and see if you can do it. Okay, so when you're done, you should get 6 and negative 5. Again, he didn't go negative 5 seconds back in time before he jumped. So it wasn't 5 seconds before he jumped. He was still on the cliff 5 seconds before he jumped. So it'd be 6 seconds is when he hit the ground. Okay. So a few more here. And again, just think, what are they really asking me? Are they asking me for a y-intercept? Are they asking me for a vertex? Are they asking me for a 0? Is it something that I could set equal to 0 and solve? So there's only so many questions they can ask. If a toy rocket is launched vertically upward from ground level with an initial velocity of 128 feet per second, then its height after t seconds is given by this equation. So they gave us the equation, and we're ignoring air resistance. We're going to pretend like there's no wind or anything. How long does it take for the rocket to come back down to ground level? So are they asking for a y-intercept? No, they didn't ask for initial height, so that it wasn't a y-intercept. They didn't ask for how high it went or when it peaked. That's a vertex. What they're asking for is for a 0. When did it come back down and hit the ground? So I'm going to set the whole equation equal to 0. I'm going to put a 0 in for height and set it equal to negative 16t squared plus 128t. Okay. Now, you could try factoring on this guy. It wouldn't be too terribly difficult. So if you recognize that it can be factored, they're both divisible by t, and they're both divisible by negative 16. So you could take out a negative 16t. What would be left would be a t minus 8. If you want to take the factoring route. If you want to do, then that means t would equal, what makes that equal 0 is 0. What makes this equal 0 is 8. So does it make sense that it had a height of 0 at 0 seconds and at 8 seconds? Well, it says it was launched upward from ground level. So that means it was steady on the ground when it started. That's times 0. How long did it take for the rock to come back down? That's 8. So even in this case, 0 is true, but it's not the right answer. It's not answering the question. If you wanted to use quadratic formula, think of this. This would be A, B, C. You have to put a plus 0 in for C. So negative B plus or minus B squared minus 4 times A times C, which that's just going to wipe that out, all over 2 times A. Now if I square 128 and then square root, that's just going to be negative 128 plus minus, then this would be 128 divided by negative 32. If I take negative 128 plus 128, that's 0. That's giving me this one. If I took out minus 128, that's 256 divided by 32 is 8. So that gives me my 2 answers. So there's 2 ways of doing that one. And then water balloon is thrown in a path modeled by this. Okay, now this one, notice the numbers are different. It didn't have a negative 16 on front, and on this was in feet. The new one has a negative 4.9, it's in meters. So any of you in physics will know that this is the acceleration in meters per second squared. Negative 16 is the acceleration of gravity in feet per second squared. That's why the numbers are different. So if it's on Earth, you'll see either a negative 16 or a negative 4.9. So this is meters. Now we're talking about meters. We must be not in America anymore. We're the only country that's stubborn enough to stick to feet. But a balloon is launched up with this path where h is meters above the ground and t is in seconds. How high up was the balloon when it was released? That's not a vertex. It didn't say what's the highest point. It says when it was released. That's a y-intercept question. Remember the c on the end is going to be your y-intercept. So this is 24 feet. It must have been on top of a building when they threw the water balloon. How high did the water balloon go at its highest point, and when was that? That's a vertex question. This is a x, this is a y. Okay, so then the x is going to be first, negative b over 2a, and then y is just f of negative b over 2a. So negative b would be negative 27 over 2 times negative 4.9. Put that in the calculator. I get 2.755 seconds. That's my second answer. So the balloon peaked at 2.755 seconds. And then how high was it when that happened? Well, I'm going to plug that in. So it'd be h of, not f of, I should say h of 2.755. I would just use a calculator and plug it in. This comes out to be about 61.194. You could say 61.2. All depends on Math Excel, how it asks you to round it. So that's fine. And then, so that is the highest point. How long was the balloon, how long was the flight of the balloon? So how long did it set in the air? That means you're setting this equal to 0 because we want to, from the time it was released to the time it landed, how many seconds did it take till it hit the ground? When it hit the ground, it had a height of 0. So that means I've got 0 equals negative 4.9 t squared plus 27t plus 24. I'm not going to try to factor that with an a coefficient of negative 4.9. I'm not going to try to factor that. I'm not going to try to use complete the square. I'm just going to go straight to quadratic formula, and that's what this is over here. Okay, so I typed it in. just kind of showed you a picture of how to type it in. You could, like I said, this is all in one step. This is how you type it in all at once, so you don't have to have to write stuff down and repeat or anything. Like, you just type the whole thing in once, and then you can copy and paste and put a minus instead of a plus and enter again. Can't go back in time, so that must be your answer.